Okay, welcome to problem solving video number 3 in my Mr. Lewis's video series on problem solving with ratios, proportions, and conversions. So this is the second one on the conversions, which is probably the most practical, is doing problem solving using conversions. Almost all the rest of the problems I'll do using conversions. So let's take a look. In a certain gear of a bike, the ratio of pedal revolutions to wheel revolutions, notice it says pedal revolutions to wheel revolutions, so is 13 to 23. So this is pedal is the first one, this is the first one, and 23 is the wheel revolutions. So this is the pedal and this is the wheel, just to make sure you're clear on that. So if a biker pedals at a rate of 80 revolutions per minute, how fast is the wheel revolving? So wheel revolutions would be in wheel revolutions per minute. So if the biker pedals at a rate of, it tells us first that pedal revolutions to wheel revolutions is 13 to 23. So I'm going to write 13, that's pedal, to 23, that's wheel revolutions. And this has to do with the number of teeth that your gear is on in a particular gear. So that means there would be 13 teeth actually on the back, on the wheel, and 23 teeth up on the pedal. So it's always an inverse proportion on that. So anyway, this is the little gear in the back and the big gear in the front that you're pedaling on. So anyway, this will be equal to, you've got 80 revolutions per minute is for the pedals. It's pedaling at a rate of 80. So that's 80 pedals in a minute would be pedal revolutions. I suppose we could write it all out. Would be how many wheel revolutions? In 1 minute you do 80, and in the same amount of time, how many wheel revolutions would that be? That would be X. So that's going to give us our wheel revolutions in a minute. So we just get cross multiply 80 times 23 and divide by 13. That's a good old proportion, right? So that is 80 times 23 divided by 13. And so we get 80 80 times 23 divided by 13. Now this is not going to come out exact. It says 141.5384. I'm just going to go 141.5 because no one's really pedaling at exactly 80 pedal revolutions per minute. So these practical problems are all going to be pretty well rounded off. Now that's going to be wheel revolutions. That is in a minute. So we'll say per minute because these were all in minutes. Per minute. So 141.5 wheel revolutions per minute. I guess I'll squeeze in revolutions there. Now, that's pretty straightforward. Now it says, how fast is the bike traveling given that the diameter of the tire is 27 inches? So you probably have not seen a problem like this. So let's introduce something here. It says, write your answer in miles per hour. So to begin this, if you want to find out how fast a bike is going, and it gives you the diameter of the tire. Now, if it tells you that we're going 141.5 wheel revolutions in a minute, that is a speed, that's a rotational speed. And what's important is that if the diameter is 27 inches, what you need to know is how far will the bike go in a single revolution? Well, the bike tire, if the diameter is 27 inches, all the way across, then what's the distance around that tire? It means if it does a whole revolution, it'll travel along the outside of the tire, which means it will go the circumference. The distance that it travels in one revolution will equal the circumference of the tire. So we need to know the circumference formula, which, again, this is something you do need to memorize or write down on your 8.5 by 11 inch sheet of paper. The circumference of a circle, there's two formula. One is 2 times pi times the radius. And the other is, since there's 2 times radiuses in there, the 2 and the radius together gives you the diameter. So you could also have the diameter times pi. So the diameter is 27 inches. So the circumference in this case is 27 times pi inches. So the circumference, or the distance it travels in one revolution, is 27 pi, and that's going to be inches. Well, the fact that this is the circumference, that's one revolution. Now we know that it's traveling at it's rotating 141.5 approximately wheel revolutions per minute. So that's what we're starting with. 141.5 wheel revolutions. We know we're talking about the wheel now. Revolutions per 1 minute. We're going to do a conversion that changes revolutions to miles and minutes to hours. So we're going to convert this, and it doesn't take much. So watch. I'm going to rewrite it down here so I have plenty of room to write the whole thing. 141.5 revolutions in 1 minute. Now we want to get rid of revolutions and find out how far it goes instead of how fast the wheel's turning. So we have revolutions here. If we put revolutions down here, 1 revolution gives us a distance of 27 pi inches. So I know we could approximate 27 pi inches and get the number for that, but I'm just going to write it as 27 pi for now. If you multiply 27 times, you could use 3.14. My calculator, most of our calculators have a pi button. You can just hit that. That's 84.82300. You could round that off if you wanted. If you wanted to write that as 84.823, that would be fine to round it off that many inches. We'll do it later. So that'll get rid of revolutions and get you inches. Now they want our answer in miles per hour. So far I've got inches and minutes. So I want to get rid of inches and get to miles. So notice it gave us that 1 mile is 5,280 feet. But we've got inches, so we have to get rid of inches, and we can convert inches to feet. These are just linear inches, not square inches, so 12 linear inches is 1 linear foot. We can convert inches to feet by using that unit ratio. And then we can change feet to miles, right? And we know that given this, 5,280 feet is 1 mile. So that'll get rid of inches. That will reduce out feet as well. But now we have minutes still in the denominator. So notice the numerator, all the units are reduced except for miles, which is what we needed. And in the denominator we have minutes, and we need hours. So how do we get rid of the minutes there? We need to put minutes in the numerator up here to get hours in the denominator. And we know that there's 60 minutes is equal to 1 hour. Notice again, I always wait to put the units in or the numbers in until after I put the units in their appropriate place so that they will reduce diagonally, because this is all multiplication and we can reduce numerators and denominators. So now we've got all this multiplication in the numerator, all this in the denominator. We could do some reducing if you wanted. 60 reduces with 5,280 really nicely. We could at least reduce the 0 there and the 0 there by dividing both by 10. Gives us a little smaller number. But I'm going to multiply all that numerator, those ones I don't need to multiply obviously, and then I multiply all the denominators and get all my miles over hours. So that will give me, so I've got 141 times the 27 times, that's 27 times pi. You could put 3.14 in there if you wanted, but yeah, all right, it's right, 3.1415, or 16 actually is about approximated, and then times that by 6. 141 times 27 times pi times 1, which you don't need, and 6. So that is going to give me 71,760.4. I'm just going to do dot, dot, dot there. And in the denominator, I'm going to get 12 times 528. So I reduced out those zeros. And you don't have to do any reducing if you just use your calculator. And now I'll divide this. 71,760 point, I'll just put it in, 4272, divided by the 6,336. And I'm getting 11.3 when I do that division. So 11.3 miles per hour, or you can just write mph. That's an approximation. Okay? And that is how you do that type of conversion. You can watch that a couple of times to make sure you understand it.